Okay, hello everyone. My name is Reagan Deshaw. The date is January 2nd, 2020. And today I'm going to be talking about feedback loops in the non-gravid female reproductive system. Okay. Okay, so like I said, we'll be talking about the female reproductive system primarily, but there are some core similarities between both the male and the female reproductive system. So we'll overview that real quick. So like many other systems in the body, the brain plays a very important role, the hypothalamus and pituitary gland in particular. Now, remember, the testes and the ovaries, the sex organs in the reproductive system, are not functioning until puberty. So what we talk about today applies to those going through or having gone through puberty and obviously haven't gone through menopause. But anyway, the reproductive system starts at the hypothalamus, which produces a hormone called the gonadotropin releasing hormone, or GnRH. These hormones then stimulate the anterior pituitary to release luteinizing hormones and follicle stimulating hormones right here. And these hormones play a critical role in affecting the gonads of the individual, so either the testes or the ovaries, and the ovaries are what we will be focusing on today. So a woman's menstrual cycle is about 28 days long, broken up into two phases. There's the follicular phase, days 0 to 14, and the luteal phase, days 14 to 28. So the first 7 days of the follicular phase is the shedding of the uterine lining, as you can see right here, which is also called the menses, and is when the woman is undergoing her period. And this is where we will start in our analysis of the women's menstrual cycle. So this is where most of the important stuff is going on in the female reproductive system, the ovaries. So remember how I said the anterior pituitary secretes luteinizing hormones and follicle stimulating hormones. So those hormones travel down to the ovary right here, travel down to the ovaries, and start to trigger some other functions. At the beginning of our diagram here, you can see there are plenty primordial cells in the ovary. And in this moment in time, the woman is shedding her uterine lining, but we're just going to focus on the ovaries right now. So you can see these primordial cells, and each month some will mature and grow into primary follicles. It is due to the FSH that these follicles mature and grow, which is again happening with females on her period. These maturing primary follicles begin to secrete estrogen from their granulosa cells, and estrogen has a negative feedback loop with FSH for the first 10 days, meaning an increase in estrogen will cause a decrease in FSH. Now, this makes sense. If estrogen is being produced from the follicles, then the follicle stimulating hormones are doing their job and no longer need to work as hard. So therefore, estrogen has a negative feedback loop with FSH. And this portion of the follicular phase where the uterine lining is shedding is again called the menses. So after the period has come to an end, we enter the proliferative phase, as you can see right here. Now, after the first 10 days of the menstrual cycle, estrogen starts to have a positive feedback with FSH and LH. So around day 10 to 11, the estrogen increase triggers the luteinizing hormone to spike, called the luteal surge, and the FSH will increase a little as well. And it's this massive spike that will trigger the ovulation of the most mature follicle in the ovary. So this one, as you can see. Ovulation is when the follicle releases what we know as the egg, so this little thing, or the oocyte, out of the ovary. So, like right there, that would be ovulation. And this happens in the very middle of the menstrual cycle, about day 14. So the egg will then travel down the fallopian tube to become fertilized by a sperm, or later be secreted by the next period, but that's a whole nother video. So anyway, as soon as the oocyte is released from the ovary right here, the LH concentration will drop back down, and the FSH will drop back down as well. And then the gonadotropin releasing hormone that has been slowly increasing throughout this whole cycle will start to drop back down. And this is the end of the follicular phase and the beginning of the luteal phase. Now, here is just a nice representation of what's going on in this menstrual cycle. So what we've seen so far is up to day 14, the maturation of the follicle right here. and the release of the egg or the ovum. So we can trace the hormone concentration and see that estrogen in gray has been gradually increasing this entire time because the follicle has been increasing and therefore releasing more estrogen. And the FSH and LH in blue and pink show a slow decrease from days 1 to 10 and then surge right before ovulation right here. After ovulation, as soon as the ovum comes out of the ovary, you can see the FSH and the LH decrease along with the GnRH that isn't shown here. And then the estrogen also decreases here in gray, but there's still a nice detectable amount of it throughout the luteal phase until about the end. But now the luteal phase is called the luteal phase because after ovulation, the follicle that released the egg turns into a corpus luteum, which is basically a dead follicle. And this follicle degenerates throughout the rest of the cycle, but it still secretes hormones while doing so. So it secretes estrogen, inhibin, and progesterone, which progesterone is shown here in purple. And going into about the 21st day of the menstrual cycle, so right here, progesterone is increasing, inhibin is increasing, and estrogen is decreasing, but like I said, it's still detectable. So again, like I said, progesterone and inhibin increase in luteal phase. So you can see inhibin, there's progesterone, and this is the luteal phase. And progesterone, shown in green, is the most important hormone in luteal phase. It has a negative feedback effect on the hypothalamus, inhibiting secretion of the GnRH, therefore inhibiting secretion of LH and FSH. Progesterone also stimulates endometrial growth, which is the lining that is shed during the menses. So progesterone is crucial for proper endometrium growth. Inhibin essentially inhibits the follicle secreting hormone or follicle stimulating hormone, which makes sense because there is no need for follicle stimulation anymore. As we reach the end of the cycle, about days 22 to 28, the corpus luteum is degenerating and no longer secreting these hormones of progesterone, inhibin, and estrogen. You can see the decline in the graph right here. With no corpus luteum, the progesterone levels decrease, and progesterone can no longer inhibit the gonadotropin-releasing hormone from the hypothalamus. So therefore, the GnRH levels will increase, and a new menstrual cycle will occur. And also, because of the decrease in the progesterone, the endometrium, so the uterus lining that was shed, can no longer, or the endometrium lining that has been growing this entire cycle can no longer be maintained, so it will shed. And this is known as the period. And so then that brings us back to the follicular phase, and the cycle just keeps on going. And so then this graph, as you can see here, right here, this day 28 is also the same day as day 0. It just goes right back into the cycle again. So, all right, that is just a quick look at the feedback loops in the non-gravid female reproductive system. And I hope you learned something while watching this. I hope you enjoyed this video, and thank you for watching. Here's my references, and again, thank you so much. All right, have a good day.